Hi, everybody. We're doing 2.4, combinations in the binomial theorem. So the formula for combinations, the formula for permutations, as you recall, was n factorial over n minus r factorial. That n is, in this case, n is 4 and r is 3. The formula for combinations is very similar, and here it is. It's let me just highlight it. So the formula, here's the formula, and it's the formula for n and k are non-negative. The number of, then the number k of k element subsets of an n element set is equal to n factorial over n minus k factorial times k factorial. So really the only difference here is really this one little that one little k factorial right there. That's really the only, that k factorial is the only way that this differs from the permutation. Now the difference is, if I want to choose a president, a vice president, and a secretary, out of a class of 10 people, well, then then it's permutations, because whether it's because it's, let's say I have Bob, Sally, and Jim. So Bob could be president, Sally could be vice president, Jim could be secretary, or Sally could be president, Bob could be vice president, Jim could be secretary, Jim could be president, Sally could be vice president, whatever. So you have all these different possibilities. But if I would say I want to make a 3-person committee, I just want to choose a committee. I have a class of 10 people. I need to make a committee of 3 to deal with whatever, to be in charge of something. So there, that's combinations, because as long as I have Bob, Sally, and Jim, that's all. It doesn't matter. It's not that one is the president, one's the secretary. No, they're just 3 people in this committee. So it's kind of like, as it says, it's kind of a subset. And that's why it makes sense that I'm dividing by, see, if I take permutations and divide it by something, it makes it smaller. You see, because once I pick 3 people, once I pick Bob, Sally, and Jim, so if it's permutations, there are 6 different ways that could work out, of who's president, who's vice president, who's secretary. There are 3 factorial ways that could all happen. But when it comes to combinations, only 1. So it makes sense. It's going to be fewer. So this is the formula for combinations, and I would use it for a problem just like that. How many? So let's go back to that. Let's go to the row here. So how many 3-person committees can I make out of 10 students? So it's going to be so it's basically going to be 10 times 9 times 8, and I'm going to divide it by well, really I'm going to divide it by 1 times 2 times 3. And the reason for that is because really on the top you have 10, 9, 8, 7, 6. That's what you have on top. And on the bottom, let me just then underneath it, you're going to have n minus 3, which is you have 10 minus 3 factorial times 3 factorial. But if you notice, this is equal to the bottom is equal to 7 factorial times 3 factorial, and um, but the 7 factorial, that's going to cancel out with this 7 right here. Actually, I don't want to. That's what I want. Okay. So the 7 factorial, let me get rid of okay. So the 7 factorial cancels out with that, and that's why I get, that's why I'm going to want getting 1098 over 1098 divided by 123. And that, of course, equals, what does that equal? It equals 10 times 3 times 4. That equals 120. If I did this in my head right. Um, I kind of divided by 6, which means I'm dividing the, yeah, 15, yeah, it's 120. All right, yay. Now, the next thing is the amazing phenomenal binomial theorem. And the reason I say it's amazing and phenomenal is because it is amazing and phenomenal. So let's go to the binomial theorem. The binomial theorem tells me, hold on, drum roll please. This is one of the most famous theorems. You've probably heard it. If I have an expansion, x plus y to the nth power, so the coefficients here, that's, and by the way, this is the famous Pascal's triangle, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Well, the coefficients here, that is 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, and 5 choose 5, the coefficients. And that is quite remarkable. And it turns out that that's really what the binomial theorem tells me, that the coefficient of x to the n minus k times y to the k is going to be n choose k. And here's the binomial theorem right there. And that is just awesome. That's very, very awesome. Very famous and very awesome. Now, suppose I would ask you the following question. How many subsets of 1, 2, 3, 4, 5, 6 contain at least 4 elements? Well, this is going to be, again, if I want to know how many 4 element subsets there are, that's going to be, as we explained, 6 factorial divided by 2 factorial times 4 factorial. That's the formula. And this equals the number of 4 element subsets. But we said at least 4. So we need to know the number of 4 element, 5 element, and 6 elements. So we need to know all of those. We need to know because I said at least. Well, that's no problem. The number of formulas. And by the way, we're making it's going to be 1 factorial times 5 factorial. And the number of 6 element subsets is going to be 6 factorial over 0 factorial times 6 factorial. Now, by the way, where am I getting this from? Because this is equal to 6. This is equal to 6 factorial. This is the formula. This is 6 factorial over 6 minus 4 factorial times 4 factorial. That's what the 2 is 6 minus 4. And this, of course, the 1 there is 6 minus 5, and the 0 is 6 minus 6. Let me just And what is this going to equal? This is going to equal this is going to equal 1. That's going to equal 6. And this is going to equal, let's see, 6 times 5 divided by 1 times 2. This is going to equal 30. So the answer, the final answer, I'm going to write as a sentence. 37 with at least four elements. And that is how you do that. Okay, everybody, it's been loads of fun. That's the end of the section, and we'll see you guys next time. Bye.